Good morning. So today what we're going to do is finish up inequalities with absolute value inequalities. Absolute value inequalities are special because, remember, absolute values just means the distance. The absolute value of a number is its distance away from 0 on the number line, or its magnitude, right? So if I'm looking at an inequality with an absolute value, like for instance, consider the absolute value of x being less than 10. If I want to look at that on a number line, well, first we're checking the distance away of the number line from 0. So it says that this distance, x, is less than or equal to 10 away from 0. So I can go 10 positive away, or I can go negative 10 away. And the distance is less than 10. So remember, less than or equal to 10. So if it's less than or equal to, it can be equal to negative 10, so I'm going to use the closed circle. It can also be equal to positive 10. And we want all the numbers going distance less than 10. So if I need to go this way, if I'm coming from negative 10, so I want all of the numbers greater than negative 10, but I also need to go this way if I'm coming from positive 10, because I want all of the numbers less than 10. Okay, so all of these numbers fulfill the inequality. Absolute value of x is less than or equal to 10, or the distance from 0 is less than or equal to 10. Alright, and how I would write that is I've got two conditions, right? Either x is greater than or equal to negative 10. And so notice how that flipped from up here. It says the absolute value of x is less than or equal to 10, but if I'm going from this point, if I want to write that out, it's x is greater than or equal to negative 10. And then also my other condition, so remember, and I've got two conditions here that they both must be satisfied. X is less than 10. So notice how this one was actually the same position. I've got x is less than or equal to 10, much like I have up here. Absolute value of x is less than or equal to 10. Alright, so consider x, or absolute value of x is greater than 7. Okay, so that means that the distance from 0 has to be greater than 7 for x. Okay, so I'm going to put both positive and negative 7 on my number line. In this case, it's just greater than, so those are going to be open circles. And I want numbers where my distance from 0 is greater than 7. So I'm going to go to the right from 7, because I want all numbers that are distance greater than 7, so this way. And from the left from negative 7, because I want all things that are greater distance this way. Okay. Now in this case, it looks like it's not an and, because these two conditions are very different. I can't have one that satisfies both at the same time, but I can write it out. So my first one, x and negative 7, well, I have an open circle, so it's not including negative 7, but it's everything that is less than negative 7. So notice how, again, I flipped the sign for the negative. It went from being greater than to less than. And that's because anytime I plug in a negative value to the absolute value, it makes it positive. Okay, so I'd want something like negative 8, which is right here, to go in up here, because it will be positive 8 once the absolute value is done. And positive 8 is greater than 7. Okay, so, and then from this side, I want everything greater than 7. Okay, so x is greater than 7, x is less than negative 7. Okay. And this one is an or. Okay, so let's try some practice problems. Now, for example, I've got absolute value of x plus 5 is less than 16. Okay, so just ignoring the fact that there's an x plus 5 in here at all, I know that this absolute value has to be at least 16 away from 0. So if I make a practice one up here, I've got 16 and negative 16. So we want values of this on the inside to be less than 16. So I need the distance to be less than. So it's open circle because there's no line underneath. It's not equal to. Okay, and I need the distance to be less than. So if I'm starting here, the distance from 0, all of the points less than is right here. And if I start from 16, the distance from 0 being less than 16 goes this direction. Okay, so my solutions have to be somewhere between here and here. Okay, so remember earlier when we were making, or up here, or up to the top, we had x, we wrote it out. X is greater than negative 16, x is less than 16. Well, I'm going to do the same thing here, except for instead of x, I now have x plus 5. So I have x plus 5 is, and if I look, greater than negative 16, and x plus 5 is less than positive 16, okay, because it goes this direction. I want everything less than 16. Okay, and now I just have to solve for x and graph. So I subtract 5 from both sides on this one to get x by itself. So I get x is greater than negative 21. And I subtract 5 from both sides on this one. So I get x is less than 11. Okay. Notice how, again, for the negative value of negative 16, the sign flips. Okay. But when I go to graph that, those are going to be in two positions. So I've got negative 21 and positive 11. Open circle on both because there's no line underneath. Now graph it in the right direction. Remember, check your zeros. So if I check 0, 0 is greater than negative 21. That's true, so I want to go toward 0. If I plug in 0 for the second one, 0 is less than 11. Also true, so I want to go toward 0. Alright, so now I want you guys to try example 2 on your own. Just notice how to set it up. I've got x plus 5 is greater than negative 16, so I flip the sign, and x plus 5 is less than positive 16. So use that method where I flip the sign, make the other side negative, and then do the regular positive to solve example 2. So pause the video real quick and try it out on your own. Okay, so what you should have done, so now this inside, the distance has to be at greater than or equal to 6. So my first one, I have 3x is greater than or equal to 6, and 3x is less than or equal to negative 6. Alright, so if I solve this first one, I've got 3x is greater than or equal to 6. I'm going to divide both sides by 3. Okay, so I have x is greater than or equal to 2. Okay, now I'm going to come down and graph that on my number line. So what you should have done is, since this is greater than or equal to, it's a closed circle. Right, and it's a 2. Right, plug in your 0 to check. Is 0 greater than or equal to 2? Nope. So I'm going to go away from 0. So my line goes this way. I want values greater than 2. Alright, so for the second one, again, you're dividing by 3. But remember, you flip the sign because you made the other side of this negative. So we got x is less than or equal to negative 2. So here on my number line, I've got my negative 2. Less than or equal to should be a closed circle. Check your 0. So 0 is less than or equal to negative 2. Okay, and so that's what you should have gotten. Alright, so we have 2 more examples. We've got a greater than example and a less than or equal to example. Okay, so this first one, note I've got an inside of the absolute value, negative 3x plus 12 is greater than 3. Okay, so I'm going to practice again with my number line up here. So this inside, this inside is absolute value. We're not caring about that right now, but we want to know where are all of these values greater than a distance of 3 on the number line from 0. Okay, so we know that we have to at least be at positive 3 and another distance of negative 3. So both of these are at least 3 away from the number line. And I want to be bigger than that. All right, so I need to be 3 more. So we've got an open circle, so we want it to go to the right on this side because we want all of the distances greater than 3, and on this side we want to go to the left. So again, I'm going to set this up 2 different problems because this inside piece, negative 3x plus 12, can be greater than, because it's going to the right, so anything bigger than 3. And the other option is that it can be anything less than or to the left of negative 3. Okay, and I'm going to solve both of these equations, so I'll start with my green one. So I've got to get the x by itself. I'm going to subtract 12 from both sides. We get negative 3 minus 12 is negative 15. And then divide both sides by negative 3. Remember, when you divide by a negative, it's an important example because we're flipping the sign. I get x is greater than positive 5, because negative divided by a negative is positive. All right, come down and graph that. So 0 and positive 5. It's an open circle because there's no line underneath, and I want to check my 0. So 0 is greater than 5. If that's true, I want to go towards 0, but 0 isn't greater than 5, so I'm going to go away from 0. Okay, so when I graph that, is everything greater than 5. All right, I need to solve this other side. So subtract 12 from both sides. I get negative 3x is greater than negative 9, and then divide both sides by negative 3. Okay, so x, since I'm dividing by a negative, I need to flip the sign again. Negative 9 divided by negative 3 is positive 3. And I'll open circle. Check the 0. Is 0 less than 3? Yes. Yes, it is. I'm going to put that on the wrong spot. Made a mistake there. 3 is over here on the number line. Sorry, I was expecting a negative. Okay, so 0 is less than 3. So I want to go toward the 0. Okay, so our final is everything less than positive 3, everything greater than positive 5. Alright. So the last example I want you to try on your own, and then I will show you how to do it. So pause the video real quick, try that one, and then we'll go through it. Okay, so what you should have done is set up two inequalities. Sorry. Got the inside here, it has to be a distance of at least or less than or equal to 21 away. So the first one I set up is 4x minus 7 is less than or equal to 21, just like normal. But the other option, I have to flip the sign, so 4x minus 7 is greater than or equal to negative 21. So we flip the sign and then change the sign of the other side. Okay. So if you've got that set up correctly, you solve for x. So plus 7 to both sides. 4x is less than or equal to 28, and then divide both sides by 4. So what you should have gotten was x is less than or equal to 7. Okay, and then for the second one, I add 7 to both sides. 4x is greater than or equal to negative 21 plus 7 is positive 4 or negative 14. Then divide both sides by 4. X is greater than or equal to, I can reduce this dividing them both by 2. So I get negative 7 over 2. Okay, got to go to graph. So we get 0. Plug in your 0 for 7. Remember, less than or equal to, you should use a closed circle. Okay. 0 is less than or equal to 7. That is true, so I want to go toward my 0. And then I've got negative 7 over 2 on the other side. And again, is a closed circle because of the line underneath. And check the 0. Is 0 greater than or equal to negative 7 over 2? Well, 0 is greater than all negative numbers, so I'm going to go toward my 0. And all of the solutions between negative 7 over 2 and 7 are correct. All right, so you've got 3 practice here. I want you to try for tomorrow's class. We'll go over tomorrow. Have a nice night.